Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know for your upcoming algebra test. So for most people, they think of algebra as that area of maths that has all the letters. Algebra is basically just a study of operations like addition, subtraction, multiplication, and so on. So in algebra, we do use letters. We call them pronumerals. We use letters to stand for a number. That's basically what pronumeral means. So if I am X years old now, how old will I be in 7 years' time? So in 7 years' time, I'm just however old I am now plus 7. See, the thing is, we don't know how old I am now. I could be 50, I could be 30, it doesn't matter. This just says in 7 years' time, I will be my current age plus 7. We do things like this because in maths, it happens all the time that we want to do things, we want to perform operations on unknown numbers. So this is our final answer. We have to get used to our answer not being one number. You can't tell how old I'll be in 7 years' time because you don't know X, you don't know how old I am now. This is just an expression that gives an indication how old I'll be in 7 years, my current age plus 7. If I give 3 chocolates to each of my Y friends, how many chocolates do I give out in total? So Y is a pronumeral. It is standing in for an unknown number. We don't know what Y is. We don't know how many friends I have. It doesn't matter. We can still write an expression. So if I have Y friends and I give 3 chocolates, the total number of chocolates is just going to be 3 times the number of friends I have. So it's just going to be 3y. Notice in algebra, if we don't write an operation, it means times. 3y and 3 times y are the same thing. It's just mathematicians are lazy. We don't write things we don't have to. So if you ever see something like 3y, it means 3 times y. 4x means 4 times x. So if you give 3 chocolates out to a number of friends, the total number of chocolates you give out is just 3 times the number of friends. We don't know what y is. We don't know how many chocolates were given out in total, but we don't need to. So there's a few definitions that we need to know. So term, expression, equation, coefficient, and constant. So I'll illustrate what those mean with this here. So here, 4x minus 5y plus 3, this is an expression. It's just a sequence of terms. Each of these is a term. 4x is a term, negative 5y is a term, positive 3 is a term. You can identify terms as they're separated by minus or plus signs. So this expression has 3 terms. An expression is just one or more terms. So this is not an equation because it does not have an equal sign. So in this expression with 3 terms, there are 2 pronumerals or 2 variables. X is one, y is the other. So the coefficient of x is 4. Coefficient just means number in front of. So the word coefficient will come up heaps throughout your maths career, so make sure you know what it means. So the coefficient of x is 4. The coefficient of y is actually not 5, it's negative 5. The number in front of y is not positive 5, it's negative 5. So coefficient of x is 4, coefficient of y is negative 5. 3, on the other hand, is called a constant term because this term here has no pronumeral or no letter. It is a constant because the value of 3 doesn't change. A pronumeral, on the other hand, is a variable. Its value changes, and you've seen that when we do substitution. The value of x changes from question to question. It varies. That's why x is a variable. The value of y changes from question to question. It varies. That's why y is a variable. But 3 is a constant. It is constant because it doesn't change in value. 3 always means the same thing from question to question. All right, let's now actually look at some substitution. So substitution basically means to exchange. Like in sport, when a team makes a substitution, they exchange or swap one player for another. So in maths, when we're talking about substitution, we're exchanging something for another. In this case, we're actually exchanging a pronumeral for a number. So the kind of question you need to be able to do, you'll be asked to evaluate an expression. So evaluate just means give the value of or say what it equals. So x equals 3, y equals minus 4. So we're being told here we're going to substitute y for minus 4. We're going to swap y for negative 4 and tell what this equals. Now remember, 2y doesn't mean the first digit's 2 and the second digit's y. It means 2 times y. So what we do is we take expression 2 times y, and I'm going to change y to negative 4. I'm going to exchange it for negative 4. And of course 2 times negative 4 is negative 8. And we're done. What about this one here, 4x minus y squared? Well, we're going to, as the question asked us to, we're going to exchange or swap x for 3 and y for negative 4. So we're going to change x to 3, and I'm going to swap y for negative 4. And then we're going to say what this equals. That's what evaluate means. Tell me what this equals. Give this a value. So we need to employ order of operations. We do what's in the brackets first. So I'm going to leave the 4 alone. 3 subtract negative 4. Remember, subtracting a negative makes it a positive. 3 plus 4 is 7. So here we have 4 and 7 squared. Remember, if no operation is written in algebra, it's a times. Now, BidMaths tells us to do indices or powers before multiplication. It goes BI, I for index, that comes before multiplication. So 7 squared is equal to 49. 4 times 49, 4 times 50 minus 4 is 196. So that's our final answer. Whenever you're asked to evaluate anything, your answer should be one number and one number only. All right, let's now look at some operations with terms. So we learned before what a term is. It's just a sequence of numbers and pronumerals. 4x is a term, 4y is a term. All of these here are terms. We're going to look at adding and subtracting, as well as multiplying and dividing terms. So how do we add and subtract terms? It turns out you can only add or subtract terms if they are like terms. Like terms have the same pronumerals. So 4x and 4y, they are not like terms because they have different pronumerals or different letters. Sure, they have the same coefficient, but they don't have the same pronumerals. So you actually can't add 4x and 4y. You also can't subtract them. On the other hand, these two terms are like terms, 7ab and 2ba. It doesn't matter that their coefficients are different, nor does it matter the order in which they are written. AB and BA are the same. Why is that? Because if no operation is written in algebra, it's a times. A times B and B times A always give you the same answer no matter which values we choose for A or B. What I mean by that is that the order of multiplication doesn't matter. So that's why AB and BA are the same thing in maths. So these two terms are actually like terms. That means we could add them, we could subtract them. So just note 3x squared and 3x are actually not like terms. I know this can be a bit confusing. Firstly, it doesn't matter about the coefficients. That has nothing to do with like terms. But a lot of people get confused because they think, hang on, they both have an x. Well, actually, 3x squared is the same as 3 times x times x. That's what x squared is. Squared means you times it by itself. So this term here actually has 2 x's. This term only has 1 x. That's why they are not like terms. So let's look at when we have like terms, how we can actually add or subtract. So if you have like terms, you add or subtract the terms by adding or subtracting the coefficients. So let's say we have something like this and you're asked to simplify or collect like terms. Now note, x is the same as 1x. They are the exact same thing. Again, mathematicians are just lazy, so we don't write things we don't have to. X and 1x are the same because timesing by 1 doesn't change the number. 1 times 4 is 4. If you times 7 by 1, you get 7. Similarly, if you times x by 1, you get x. So x and 1x are the same thing. So to simplify this, we're just going to look at the coefficients. We go 1 plus 6 is 7. Minus 4 is 3. So our answer is going to be 3x. If you had an x, you added 6 x's, you now have 7 x's. And if someone were to take away 4 x's, you now have 3 x's. So just be careful here. When we're adding or subtracting, we just look at the coefficients. So some people think if you have something like 7x minus 4x, then you cross out the x's. Don't do that. That's a common mistake. We don't cross out x's when we're subtracting. Final answer is 3x. So what about this expression here? Well, this one is a little more complicated to try and add or subtract. What we have to do is look for like terms. So this term here and this term here are like terms. Note, this is not 5dc, it's negative 5dc. This negative belongs to this term. So these two are like terms because they both have one D and one C. It doesn't matter, the D and the C are written in a different order. Similarly, this term and this term are like terms. This is not 7D, it's negative 7D. This is negative D, which is the same as negative 1D, because D and 1D are the same thing. So when you have an expression like this, you need to do each pair of like terms separately. So 12CD minus 5CD. We look at the coefficients. 12 minus 5 is 7. So 12CD minus 5DC is 7DC. It doesn't matter whether you write it as 7DC or 7CD, same thing. 12 minus 5 is 7. When we're subtracting, we don't cross out the pronumerals, we leave them as they are. If you had 12 CDs and you took away 5 CDs, you now have 7 CDs. Remember, DC, CD, same thing. So now we do the other pair of like terms, negative 7D minus 1D. We operate on the coefficients. Negative 7 subtract 1 is negative 8. Again, when we're subtracting, we do not cross out the pronumeral. So that is our final answer. I can't simplify this any further because this and this are not like terms. This can't be simplified any further, so we stop. All right, let's now look at multiplying and dividing terms. So most people find multiplying and dividing terms easier than adding or subtracting, and that's because you don't have to worry about like terms. You don't have to first determine whether or not they're like terms, because it turns out you can multiply and divide any terms. You can multiply and divide two terms even if they are not like terms. Again, we just operate on the coefficients. So if you have 3x and 2, well, 3x and 2 are not like terms, but that doesn't matter. We can still multiply them. So we just multiply the coefficients, so the numbers. 3 times 2 is 6, and then we just write the pronumerals. So 4a times negative 5b. 4 times negative 5 is negative 20, and then we just write the coefficient. So what about 2a times a? Important point I want to make because this is messed a lot. So a plus a, 1a plus 1a is 2a. A times a is not 2a, it's a squared. That's what squared means, multiplied by itself. So make sure you know the difference because people always mess this up. A plus a is 2a, a times a is a squared. So a lot of people would get 2a times a and they'd say, oh yeah, that's 3a. No, 3a is 2a plus a. 2a times a, so we just leave the 2 alone because there's nothing to multiply it by. A times a is a squared. So it works similarly for division. 30x divided by 5, you just go 30 divided by 5 is equal to 6, and we write the... So this one is a bit harder. 28yz divides 7y. Sometimes when you're dividing, it might be easiest to write as a fraction. So we haven't done fractions yet. We'll do it later in the year, but it turns out you can cross out anything that's on the top and bottom of a fraction. Y divided by y is just 1, assuming y is not 0. Cross out. So we can just go 28 divided by 7 is 4 and write our pronumeral z. Remember, this line here means divide. Alright, thank you so much for tuning into this video. Best of luck studying with your test, but I know you're going to ace it. This has been the luckiest maths teacher in the world. Have a great day.